Hello, my name is Amir Ishaq, and I would like to welcome you back to this WebRTC Let Us Learn Together. Let us do a quick recap of part 4. In part 4, we built a mobile version using ReactNative, and we used the previous version of the web application from part 3, and we were able to make these two communicate. Basically, what you see here is actually running from my mobile. I'm going to press the call button from the mobile, which is basically sending an offer to whoever is connected, in this case the browser here. When we press the call button, it sends the SDP, the offer SDP, to the browser, and when I tap answer here, it will generate an answer SDP and send it to the mobile, and then the connection is established. If you haven't already, I highly recommend that you go and watch all the parts of this series from 1 to 4. Let's have a quick look at what we're going to achieve in this session in part 5. Okay, so we have multiple computers ready to connect. I have this tab on this computer, and then I have a Windows 10 computer with the browser open, and 2 other computers. So let's go to our website. So we have the first peer connected and waiting for other peers to connect. Okay, so let's go ahead and connect the Windows 10 machine. Now we have 2 peers connecting. So 2 peers connected. Okay, let's connect the third one. Okay, now we have 3 peers connected. Okay, now we've also connected the 4th peer. Now you can see we have 4 computers connected together. I'm able to switch between the 3 other videos. Okay, so let's first go through the basic design that I have. So we have our signaling server waiting for connection. P1 comes in and establishes a WebSocket connection to the, and then just sits there and waits. Another peer establishes a connection with the signaling server, and then soon after establishing the connection, asks the server who is connected. The server sends a list of connected peers. So in this case, there'll be only P1. Then peer 2 sends an offer to peer 1, an offer SDP. Peer 1 sends back an answer SDP in response. And then WebRTC tries to establish a connection where media starts to flow. Then we have peer 3 trying to and then peer 3 asks the server who is connected. The server responds with a list of the peers that are connected. In this case, it will be P1 and P2. However, the server does not send both in one response. It sends two responses, one for P1 and one with. Then for each, after receiving the response from the signaling server, say for example P1, it will send an offer, and on the other side it will also send. P1 will respond with an answer SDP, and P2 will also do the same. And then WebRTC media connection is established for both. This way, even if we have P4, it will do the same thing. WebSocket connection, ask who is there. It will respond with three responses, one for each, P1, P2, P3. P4 will send an offer to P1, send an offer to P2, send an offer to P3, and each one will respond with answers and connections established. That's the basic idea behind all this setup. So you can imagine if you have P5, it will be the same concept, P6, and so on. We will also see that when, for example, P4 drops the connection, then we can either know from WebSocket disconnect method or via on-ice connection state change within the peer connection object. That way we'll be able to clean up whatever needs to be cleaned up in terms of the media stream, the peer connection variables, and so on. Okay, so let's jump to code. Let's first clone the code from GitHub repo of part 4. This is the link here. Okay. Let's copy this. Okay, so let's do git clone and paste the link. It's going to create a folder called WebRTC part 4. Okay, so let's jump to VS Code and open the new folder that we've just created, WebRTC part 4. Okay, now we are ready to start modifying part 4. Let's start by modifying our UI. Let me just move this a little bit. Our new tab. Okay. Let me first open up terminal. Make sure to change directly to the web folder and npm install. Before you move on, make sure that the URL that we're using here for our connection is the right one. So let's grab it from ngrok. Okay, and then we can run our server. fast. Yes, the server is running on port 8080. But first, because we've made the URL change, we need to run build. We can test our application, and it should be working fine, as in part 4. Okay, then let's go ahead and adjust our UI. Let's start with the local video. And refresh. Okay, so now it has moved. Let's also modify our remote video. Okay, refresh. So it takes up the whole. We will not need the text area, so let's get rid of it. Okay, so we notice that our buttons and the text area is not visible. Let's just wrap them around a div. Okay. Let's go ahead and test and make sure the app is still fine. There we go. Okay. So we just did a quick redesign. Okay. Let's create a video component that we can reuse whenever we want to show a video. Let's create a video component that we can reuse. Let's go ahead under source, create a new folder, call it components, and then let's add a file called video.js. Now, because we're going to reuse this video component, for example, to display a video here, to display a video here, and later on to list the remote videos, we expect that the style will be different for each of them. So let us also set some attributes for video. Do not forget to export. Let's import video component in here. Now that we've imported our video component, let's go ahead and change now we're going to be passing in a video stream instead of video rip. Let's go ahead and create our local stream in the state object. Let's disable the video reference for local for now, because we don't need it anymore. We can disable that as well, and instead we can set the local stream to the stream that we receive on success of get user media. Okay, let's make sure that we are getting a stream and assigning it to local stream by logging to console. And let's see what happens. Okay, refresh. Let's go to console. So seems like we are getting a stream. Now we are passing it to our video component. We'll have to go and make some changes. Let's head over to video component and make some changes. The name for our prop that we're passing in to video. Okay. Okay, so our style here is called video styles. Let's go back to the component and make sure that we are passing the styles as expected. So far so good. So let's run build and let's go ahead and test. Refresh. Okay, so we have a local video working. Now we're going to do the same for remote. So for remote, after we've initialized it, we'll go and look for on track and assign the stream to that variable. So let's go ahead and test. offer. We receive on the other side and answer. There we go. So now we have our app fully functional and slightly modified. Okay. Our video component is quite complete for now. However, we need to create a container that will hold remote videos, which will display somewhere down here. So we need to create another component called videos, which will basically hold a number of videos depending on the number of peers connected. Okay, so let's just do that and create our videos components. So here I'm going to have the list of videos as they are added. So we'll have, it's in the state object. So let's go ahead and add it up there. Now we know that we are going to be passing streams, remote streams into this object. So we will need to initialize remote streams object, which is going to be an array. And then we will need to create component will receive. Now in here we're going to check first the change in streams, and then we create our videos. You will notice that this is going to be somewhat similar to the way we set up the video component in here. So let's go ahead and define the properties. video. And then once we are done, we will set state remote streams next props dot remote streams and our videos equals to our videos. Our videos object is done. Don't forget to export. Okay, let's just double check, make sure everything is okay. All right. So let's go ahead and add our videos object. And let's, for the time being, just add the videos object rather, div somewhere down here. We haven't defined remote streams, so actually this is this dot state dot remote stream. So let's go ahead and initialize it in the state object. Let's run build and make sure that everything is still okay. There shouldn't be any changes in the functionality. Let's refresh. Okay, I'll refresh on the other browser. I'll make an offer there. Make an answer, and everything is okay. Good. So nothing is broken. Okay. Let's define a few more properties. So local stream is used to hold a local stream object to avoid recreating the stream every time a new offer comes. Remote stream used to hold remote stream object that is displayed in the main screen. Remote streams, as we have just seen in the videos component, holds all the video streams, local, actually not local, but all remote streams. Peer connection holds all peer connections. Okay. Let's move a few more things up to the state object. Let's move this. And let's head to the state object and save it there. We have one more place to change in here. So Let's also have this dot service IP equals to URL. So let's go look for the URL, which is right here, and we're going to replace this with that. Okay. We don't need local video ref anymore, and we actually don't need candidates. Let me just make sure that local video ref is not in use. Let me move this to its own method. This in the top of component did mount. Let's run build and make sure that everything is okay. PC config is not defined. PC config is not defined. Obviously, should be this.state.pc config. Now run build again. Let's do a refresh and make sure that it's okay. Okay, so far so good. Remember that I mentioned in my design that adjoining peer will ask the server who is connected, and the server will return the peers that are already connected. So let's go ahead and implement. So I thought the best place is to check as soon as we get the local stream. Get user media. When it's successful, it will call this method. We have a stream. Okay, and then once we have this stream, we check who is online. So we go ahead and create that method, who is online, or basically who is connected. So we have that, and basically we just send to peer, means we're sending to the signaling server to raise this event, and we are passing our local socket ID. Let's make a change, a small change in here. Let's pass in socket ID, and therefore we don't need to, but we're already passing this.socket.id over there. We don't need to define it here. This event online peers does not exist yet, so let's go to server code and add that event. And basically what it does is it just loops through the connected peers and sends it back to the caller. You notice here we rename this to underscore socket, although we don't need it, but we're using the same socket to emit back, and on the other side it will, on the client side, to raise online peer event with the socket ID of the connected peer. Again, this online peer does not, the event does not exist on the client side. So we will have to go there and so we will have it right here. Let's restart our server and make sure that everything works fine. Okay, so this is not complete. Close that. Okay, let's run build. Let's go ahead and test. Let's refresh this. Okay, so it says connected peer AAB, online peer undefined. Okay, we'll figure that out. Let's add another peer. Okay, on this peer you can see that we have connected peer AAB here, which is that one there, and the current one, AAC. If I add the third one, now we have AAB, AAC, and AAD, 3 peers. So it's actually working. Please note, based on our design, when, let's say for example, 2 peers have already joined, now we have a third one connecting. This third one will ask the server for who are the connected peers. The server will send one by one, will emit online peers. This event will be raised multiple times depending on the number of connected peers. So for each call, we have to create a new peer connection. Let's go ahead and create this method. Okay. Okay, we've done this in the previous in part 4. So for example, on ICE candidate, you can see we did this, but we've done some modification. So basically we will have to comment this out, comment this out, on track all of the methods will have to go from here. Okay. So let's go back. Now we are just including the local and remote ID, because we are going to change in the server code as well. When a remote stream is available, onTrack method will be called. At some point, the peers are going to disconnect, so let's take care of that for now. Sorry, I made a mistake here. This should not be remote stream. It should be remote video, the one we defined up there. So let's continue with where we left off before we created the create peer connection, which is on online peer. So the next part is we need to create the offer. Before we were using a button to create an offer, but now we'll do it automatically when the peers connect. Okay, so let us now go to the server code and implement the offer. in this object we have remote and local. If you look here, so this is the socket ID being sent within send to peer. That is determined as socket ID. So we're checking if socket ID in the peers, connected peers, is equal to the remote socket ID. Then we want to send that offer to that remote. So we're sending an offer to the remote peer, and we're sending SDP, and we're also sending our local socket ID, saying that we are the ones who are requesting or offering to connect. The socket is emitting an offer. That means we need to go and create an offer event. So we'll go ahead and create the offer. Now since we've raised an answer event, let's go back to the server and create the answer event. Okay, so let's jump to the app and go ahead and create the answer event. We need to modify the onCandidate. Pretty much we need to do something similar to the other event. This means the event in the server side for onCandidate, just down here. It will not change much, but we will be checking whether it's equals to remote. Okay, and instead of the payload, to be candidate, which is going to be the payload, and socket ID equals to data.socket id.local. Let me do some cleanup. We don't need this anymore. And if you remember, we need to keep track of disconnected peers. Method here that returns, which we broadcast to all peers. Peer disconnected, and it will send how many are still connected and which peer disconnected. So we will call this method here on disconnect, and it should work. Let's also let the client know the connected peers by having the peer count in the connection success, and as soon as the peer connects, we are broadcasting the number of peers that have joined. Let's go back to the client and just do a little bit more cleanup. Let's go back to connection success. Now we are receiving data. Set status data equals to data.peer count. Remember, we are now returning we're returning the success, which is a socket ID, and peer count, the number of peers. So we're just checking the peer count if it's greater than 1. We're just changing the text total connected peers to those peer counts, otherwise waiting for other peers to connect. Let's save that to state. Let's do a little cleanup on the UI. Okay, simply just a div to display the status text, and I think we're almost done. So let's restart the server. Okay, we're getting type error, cannot read property add stream of undefined. So there is add stream. They should be okay. Okay, this one here should not be there. Unbuild again. Okay, so we have our video. Refresh again. Okay, but we're getting an error here. I realize that I have not added the peer disconnected, not an event raised from the server when the WebSocket is disconnected, and basically we just want to remove the peer from remote streams. So I had some bugs in the code, and I went ahead and fixed all the bugs. But let me show you the final product, then we'll go back to code and look at the changes that I have made to fix those bugs. So this is the end product, as you can see. I have a bunch of computers connected down here. I can switch between the computers, and I can disconnect any of the computers, and you'll notice, for example, if I disconnect one of them, say this one here, The transition is quite smooth. Even when I add back, the video appears down here. And when I select this video, this peer, and I go ahead and disconnect him, it switches to the first in the list, and that peer is removed. So as you can see, this is the other computer. You can switch between the videos. And everything is good. That's my son doing his online classes during this time of COVID-19. Let's go ahead and disconnect some of the peers and see what happens. So that's gone. That's gone. That is gone. And the other two are a little bit far away. So I'll stop here and then we jump. So let's start by looking at the changes that I made. So I started by moving the connection peers setting to after the connection. It only makes sense to have it here. So after connection, we add the socket ID of the peer into the collection. Then we scroll down to online peers and make sure that we're looking at the local ID that we send from the client. Now let's jump to application side and have a look at the changes that let's start with component did mount, and let's move this into connection success. That is, soon after we are connected to the server, then we go ahead and get the local media stream. Once that's done, then let's comment this out and use the spread operator at the selected video, and also for the streams. Since we're selecting videos, there is one method we still need to add. Let us also make sure that the remote video is the one that is selected and not the default one. Let's go up to the who is online and make sure that we are passing this ID as local. Okay, then let's jump to video and add a condition here. Let's move this inside the condition. We also don't need the on this condition here. Let us then jump to video and add components did mount. Let's check if we have a video stream. If we do, then we set it to the video source objects. Okay, and I believe we're done. Let's run build. Let's go ahead and test. We have now come to the end of our session. I hope you enjoyed this session. It was a lot of work. I'm not sure if you'll grasp everything that I said. Maybe I did not explain it in the right way, but you'll have the code on GitHub where you can clone and make changes to it as you wish. Thank you very much for your patience, and bye.